Hi folks, and welcome to today's lesson for BCIT Technology Teacher Education 4044. It's our structures class, but in our labs, I know a lot of people have been having fun with the laser cutter so far and expressed interest in getting their hands on the 3D printer. So today I'm going to talk a little bit about how to design a part for the 3D printer and then how to take that part into slicing software and make it so that you've got G-code commands that can tell the printer what to do and how to make your part for you. And the part we're going to take a look at making today is for our Big Bad Breadboard board. And you can see here that I've got the board all designed in Fusion 360. And right now on your Big Bad Breadboard board, the speaker is held in place by this doohickey right here that I call the speaker cover laser cut. Well, we can turn that part off and then we can come down here and I've designed a 3D printed version that comes down here and surrounds the speaker. So it's going to look a little bit more, here's the real thing right in here. So you've got a Big Bad Breadboard board and you've been using it for a few things and you can see there's a speaker sitting on it right here. And the speaker actually sounds a lot better if you can enclose that speaker so that you don't get sound reflections bouncing off the bottom of the board and coming back up and interfering with the sound that's supposed to be coming towards your ears. So we're going to build a 3D printed part that comes down here and it's going to fit perfectly into our Big Bad Breadboard board, and you're going to replace the laser cut part right here with a nice brightly colored 3D printed part. And in the process, you're going to learn a little bit about modeling a part in Fusion 360 and slicing that part in Ultimaker Cura, two of the software packages that we use pretty regularly at BCIT. Okay, let me turn this back off over here. There we go. So the part's going to come out looking like this red bit right in here. Before I get into that, I just want to take a moment and talk about some interesting websites that you will be interested in if you're interested in 3D printing. And one of my favorite ones is Shapeways. And not that I do a lot of stuff with Shapeways, but I tend to look to them for inspiration. They've got a really neat business model going on here at Shapeways and sort of a way to think about the impact that 3D printing or additive manufacturing, as it's probably more generally known, is possibly going to have on manufacturing over the next couple of decades. Because you're able to design parts virtually inside your CAD software, you can have them manufactured and printed anywhere. Doesn't have to be your shop. In fact, you don't have to have a 3D printer in order to do 3D printing. There are companies like Shapeways, many others out there, that have very nice 3D printers, fancier and more expensive than a small startup company would be able to afford for their own. And you can upload your files to them and they will print in a whole range of different materials. So in our shop, we're going to be using uh, a type of 3D printing known as, oh God. um, we're using PLA, and the acronym has slipped my mind completely as I'm doing this. I had everything all queued up and ready to go for this, but it'll come to me. Anyways, we'll get going on here. They've got all these different methods of making parts that are different from what we're using in our shop. We're going to extrude hot plastic. And FDM, finite deposition modeling, is what we're going to use. But they've got selective laser sintering, where they can take a plastic powder and put it into a build chamber and heat it up to the point where it's just about ready to bond together, and then blast each layer with a laser. And as the laser comes through, it bonds the plastic together. So you're able to use different materials. We're going to focus primarily on a material called PLA, or polylactic acid. They've got something called binder jetting that they can do, where this time they use steel powders and essentially run an inkjet printer over top of it, but instead of ink, it sprays an adhesive that bonds it together, and then you can sinter the remaining parts together to get actual metal parts out of your 3D printer. multi-jet fusion, similar type process. Stereolithography, they've got machines that start off with liquid resins that are sensitive to the ultraviolet. So when you blast an ultraviolet laser onto them, this was the original style of 3D printing, and it will solidify the liquid resin, and then you do that layer by layer. Selective laser melting. I'm not even sure quite how to describe that. You might have to click on that and find out more. Um, Material jetting, wax casting, so you can 3D print a very fine part made in wax and then do a lost wax casting type of thing. And Shapeways has multiple factories all around the world. So if you are living in Europe and you design a part and you want it to be manufactured, well, they'll just ship that file digitally to your Europe um, printer. Or if you're living and working in North America, but you're selling to a European client, you just send your file digitally across the Atlantic and it gets manufactured in Europe. And that cuts down on CO2 emissions for transportation, cost of transportation, and delivery time. So some really neat stuff that these online virtual machine shops and virtual 3D printing factories have available. Now, Shapeways has taken it a step further, and you can see they've got information in here. Check out the materials they have, check out the industries that they serve, okay, and the solutions that they offer. But one of the things that they've done that's really quite neat is they've also become an online store. So if you come into their jewelry solution and say you're a jewelry designer and you're designing something in Fusion 360 or Rhino or whatever software you like to use, and you've got this neat design for a ring, okay? And you want to sell that ring to people around the world. The way their business model works is you can take your file and you can upload it, and you can select the material and they can print it anywhere, and you can put this on their website, and when somebody orders that part, they'll print it, pay you a royalty, and ship the part off for you. All you have to do is sit back and collect the revenue. So now physical things have become uh, known for their intellectual property. It used to be that if you wanted to sell a ring, you had to make the ring and sell it to somebody. Now you design the ring and you're getting paid for your intellectual property, for the cleverness of your design, the beauty of your art, and somebody else is taking care of the manufacturing and the shipping for you, and you just sit back and collect the royalties. It's more like a music model, and you can actually find some really kind of neat pieces of jewelry on here, and testimonials from their designers. It's really quite cool, and I'm just looking on here. Somewhere there is their marketplace, and let's just go back to their homepage there, and we should be able to find their marketplace right in here. And so if you're interested in any of this and you're interested in seeing what other people have designed and how much it costs to get something made, go into the Shapeways marketplace and you can go in and you can find a whole bunch of really cool different designs, some of which you can actually customize because people have not only created the design, but they've made them reconfigurable. So if you want a ring on a certain size, you go in and say, okay, I want my ring to fit ring size 8 or a ring size 10, whatever, and I want it to have this many gems around the outside. Of course, you have to put the gems in yourself, but you can see these designs are pretty much single material, but all sorts of very creative stuff going on there. So if you're a creative person and that type of designer, you might find some neat stuff on Shapeways. Now, Shapeways is very commercially oriented in that, and of course, in education, we like to share our designs and share our ideas, and yeah, that's the advantage of having someone else pay your salary. Certainly, the designers need to get revenue from their designs, but for those of us who are doing it as a hobby or as an interest and just interested in sharing our designs, uh, Thingiverse is a really neat website where you can go and you can find lots of really interesting designs that people have made and chosen to share with the world. And in fact, I've put some things up on here to share just because I've downloaded things and I've used things. So for instance, one of the things that I use on the BoomBot project that we do in second year electronics is a disc cannon, and it's called the Disc-O-Matic. Let's see if that pops up right in here. There we go. And somebody's come and designed the Disc-O-Matic, and they've got pictures of what it looks like. They've mounted it on a little robot, CAD drawings, instructions on how it goes together, and here's all the different files for all the different parts that you need to make that. So you can come in and you can download the parts, and you can kick that out on your printer. And actually, as I write this, I've got one of these sitting on the Ultimaker in the shop at BCIT right now because I've started to print them out for the second year electronics class. So a couple of neat websites on there. Shapeways, Thingiverse, really cool. You can download it, thing from Thingiverse for free. Just make sure you give people credit. I don't know who Canino is, but I do give him or her credit in my comments, and thank you very much, Canino. And another website I'll just point out along the lines of sharing designs is GrabCAD, because it's got a whole bunch of really nice 3D models available in here. So for instance, if you're interested in doing a 3D model of your Big Bad Breadboard board, and you happen to want an Arduino to drop right in there, you saw I had an Arduino in that design. I have to admit, I did not create that Arduino myself. I came in here and, oh, there's a whole bunch of different Arduino type things. I was looking for an Arduino Uno, and I don't think it was this one that I downloaded and used. But you can see you can come in here, and now again, this is community driven, and everything I've downloaded from here so far has been dimensionally accurate. But people are sharing this, and oh, maybe this was the one that I used. I'd have to go back and look at my files to find out. I usually have the designer's name linked to it, but certainly I didn't go through and design the LCD screen. I did design the battery pack. I did model the speaker, but I downloaded the breadboard and the Arduino from GrabCAD. And if I take a look right in here, there we go. I used the Arduino by Kevin Schneider. So if you're designing a part and you want to get a well-known electronic component into it, or a well-known component of any kind, you can just import that part. And same thing goes for your nuts and your bolts and your screws when you're building things. Fusion 360 has the ability to go online and get any part from McMasterCar.com, McMasterCar being a big online retailer of parts. The good side, they've got a whole bunch of things. Bad side being American, they have a very poor selection of Robertson head screws. Americans, they don't understand a good screw head. All right, let's take a look at what we're going to do to create this design in Fusion 360 and then slice it and print it. Okay, so anytime I go to start a new design, I like to start out with a sketch, and that's not a sketch right there. So at first I made a really quick sketch of what I wanted to create just so that I'd have some dimensions in that handy. And what I like to say is that when you come into Fusion 360 to make something, yes, it's a drafting tool. Yes, it's a design tool. Yes, once you've got a whole bunch of experience, you can come in here and work in here. But I've been using parametric solid modeling design tools for over a decade now, and I still start with a sketch. And just because that sketch was really ugly, and this presentation is going online, I did come back and do a slight little nicer sketch with my dimensions right in there and use pencil and all that. Probably more detail than I needed to, but I wanted to make sure it was worked out and that I had a reference to start from. You've already kind of seen where we're going, so you've got an idea of what this is going to look like. We're going to have a flat surface on the top right here, and then we're going to extrude it outwards. To keep in with the original design, it's only going to extrude up about 3 millimeters here. We can come back and change that later on. And then it's going to come down a total of 27 millimeters right in there. And that should be just about the right size for fitting our speaker in. Okay, let's see, where are we going to begin with something like this? So let me turn off that screen. And let's come back to Fusion 360. And I'm just going to switch over here to the speaker cover and make sure I give you a good idea of what we want. Now, when we design this, we've got a few constraints that we have to keep in mind. One, it actually has to be dimensionally accurate, and it has to fit what we're going to make. We've got to have a hole in the side of it for the speaker wires to get out. And then the rest of our Big Bad Breadboard board has 3 holes coming through right like this. And I'm just going to stick pretty much to the laser cut design, but there is room to do a bit of freestyling in here. Now, when you're thinking about 3D printing, and particularly with our printers that we have in the shop, you have to think about how the printers actually work, because they print with one layer going on top of the other and up higher and higher and higher. So you need to have a relatively large flat surface as your base layer so that you can actually bond to the print plate. Okay, now you've got 2 possible surfaces to have as your flat surface right in here. This could be one right here. So if we keep that flat, then I can print it around this way, and I can start at the bottom and start building up right in here. Or I've got a big flat surface right here, and I could put that surface down and start building up that way. Now the catch is, if I build it up this way, that lets me put all sorts of nice smooth edges and bumps, and I could have a bunch of detail on the top. But the challenge is going to be these pieces that come into the middle to protect the speaker diaphragm. If I look at that from down below, I'm going to start printing up this way, and this is all going to be hollow in here. And then all of a sudden, I'm going to try to print this face right inside here. And there's going to be no support underneath that. Now, when we get into the 3D printing software, I am going to talk about something called support material, but ideally, we'd like to avoid support material if we can possibly avoid it. So what I'm going to do is I'm going to flip it over, going to put this down this way. This side right here is going to sit right flush on the print bed, and we're going to start building up right around here, and it's going to come out on this side, and it will be beautiful, and it will fit perfectly because we took all our measurements. Okay, so this is the thing that we're building. The way that we're going to build it is by starting with a sketch on this plane right here to determine the dimensions. Then we are going to extrude that upwards. Okay, now we're only going to extrude it upwards 3 millimeters because we're going to come to that surface right there, and then we're going to use that surface as our reference to extrude the remaining project 24 millimeters to come right up here. Finally, we're going to come back in and we're going to put a hole in the side of it so that our speaker wire can get out. Okay, so you've used Fusion 360 a little bit before. This is maybe the first time you're designing a part in it, so I'm going to go through and talk about some of the things as we do that. So you're going to come in here and say, I want a new design. Okay, and you should have a nice blank screen looking something like this. And along the top, you've got some tools for creating things, modifying things, and later on when we go and put things together for assembling things, but we're not going to need the assemble just yet. A couple of useful tools are Construct. We'll use that for making construction planes because we're working in a 3D space. Not everything is on the X, Y, and Z axis, so sometimes you need to create new axes and planes to serve as reference surfaces. And then we've got the inspection tools over here, which we can use to take dimensions off something, measure how far apart 2 things are. Lots of useful stuff. And of course, Insert for putting different parts into your drawing. That's how you'd get your GrabCAD materials into your design if you had a multi-part design coming together. We're just going to be creating a single body or a single part or a component, and later on it can go together into the Big Bad Breadboard board, which is an assembly of components. Okay, you probably don't have all of these files right in here. You might already have some. But let's start out by just saving our file and giving it a name. Okay, and let's call it 3D printed speaker cover and then put your name at the end of it. Maybe you don't need a dash in there, okay? Just because if you're sharing the file with me and saying, hey, this isn't working or something like that, and you've got your name attached to it, then I know whose file I'm looking at. When you go to 3D print it, you'll want to have your name attached to it as well. Okay, so we've got the file open, we've got it saved. Later on, when you get more advanced with using Fusion 360, there's some really neat surface and sheet metal tools, and we are going to use the tools later on to export the STL file. Alrighty, so the first thing that we're going to do in here is just about everything in Fusion in design works by creating a sketch. So we're going to come in here and click on the Create Sketch button right here, and this little box pops up and it asks you what plane do you want it to be on. Honestly, you can't get it wrong, okay? Because when it comes time to assemble, we're going to just rotate it into position in whatever orientation we need it. But let's start with what we'd call the YX plane down here, okay? Because Z is coming straight up. We're working on the Y and the X. You can see Y is in green and this axis in green. X is in red. This axis is in red over here. And it's got some dimensions worked out right in here. Now, a couple of things that I should have mentioned just before we got going is to check in your design when you installed Fusion 360, come up to the top corner and let's just click on here and go to your preferences. Okay, and in your preferences right in here, there should be down at the bottom for your default units for your design, just make sure you're working in millimeters. Okay, Cura and our 3D printers like to work in millimeters. It's not a big deal if something comes in inches or in centimeters because we can just scale it by a factor of 10 or a factor of 25.4. But anyway, in Fusion, I'll recommend that you set things up in millimeters. And I think that's probably been working for you okay so far. You can also, in your electronics, weirdly for our electronics, we're going to work in inches and thousandths of an inch. So yeah, typical Canadian, fluently bilingual in 2 different measurement systems, even though one of those measurement systems is stupid. Alrighty, let's carry on right here. And what we're going to do is we're going to start by taking a look at that sketch that I had laid out. And we're going to start with the simplest part of the design, which is going to be the main circle with a 35 millimeter radius. So your circle tool is right up here, and we're going to create a circle, and we're going to create that circle. Come down here and just click right on the origin. Doesn't have to be the origin, but it's a nice point of reference. And you can see as we draw that circle out there, it's asking us what diameter do you want to make that? So I said it was going to be a 35 millimeter radius. Let's make sure we make that a 70 millimeter diameter circle. Okay, and it shades it in nice and solid for us. At this point, you may need to zoom in or zoom out. Now I'm using my center mouse button, and I will also from time to time be using my ever handy 3D mouse from Connection. 3D Connection makes really nice CAD toys, so if you're watching 3D Connection, send me more, and my dozens of subscribers will no doubt run out and buy your product. It's not the best way to become an online influencer, I don't think. Hour-long painful lectures. Alrighty, let's take a look in here and see what we're going to do next. Now, before we go too much further, I'd like to point out one of the really cool things that Fusion 360 and similar programs like Autodesk Inventor and SolidWorks and Onshape, which is an entirely online cloud-based parametric solid modeling program, have that AutoCAD doesn't. So in AutoCAD, if you drew the circle the wrong diameter, and you wanted to go back and change that diameter, you'd have to erase it and then draw a new circle in the correct diameter. And if you had a dimension and everything like that, would be a royal pain because you'd have to go back and redimension everything. In parametric CAD, okay, just come and click on the dimension. And if that was supposed to be a 60 millimeter diameter circle, type in 60. If it was supposed to be 10, type in 10. Um, Now, this is really cool, very powerful. We've got undo right up here, so let's put that back to 70 where it belongs. Very, very powerful. But part of the challenge when you start designing things in here is that because everything can be changed, all the parts have to be interlinked to each other using what we call constraints. If you want to get the full benefit of parametric CAD, those parts need to be able to link to each other. Okay, so we've got the outside circle drawn in there. There's going to be a 26 millimeter radius inside circle, which is 52 millimeters in diameter. Um, let's create a circle right here. And now you can just type in 52 millimeters in diameter for our inside circle. Okay, so now you can see that we've got this outside ring coming right along here, and this is laying out the groundwork for our circle. Now we've got 3 bolt holes. One's going to come in right here, one down here, and one over here. Now these spaces are spaced radially and nice and even. You've probably used a circular array in AutoCAD. We're going to use a similar tool in here. In here, you're going to have to drop down on the menu to find it. They call it a pattern. Okay, but before we can use the pattern, we have to create the parts, and we want to make sure that we've got things in the right position. So to do that, I'm going to create some construction lines, okay? Everything that we've created so far has been object lines. So now I'm going to come in here and I'm going to turn on the construction tool, and I'm going to draw a line, and going to start right at the middle. Make sure that it snaps onto that middle and that it's holding on to the center of that circle. And then I'm going to come right in here, and you can see I can put it anywhere that I want, but my dimension is highlighted on the side right there. So I am just going to type in that I want those circles to be at a 31.5 millimeter bolt center. So I just go 31.5, okay? And now it puts that dimension in there. Now, you don't have to worry too much about dimensioning rules while you're creating your sketch, okay? Because as you know from your CAD class, if you submitted a drawing and you had the dimension drawing right over top of object lines, you'd get big red X's all over it, and that would not be a professional caliber drawing. This is not going to be the drawing file that we output, okay? This is just a sketch for putting the part together, and so you've got some flexibility in where you put those dimensions. Later on, when everything's all done, you can turn this into a nice, orthographic drawing with hidden lines. Very cool features in there that goes through and figures out all the hidden lines and everything for you. All right, so now we've got the location of the center hole for our bolts. I'm going to turn my construction tool off, and I'm going to create a circle. And this time I'm going to make sure I snap right onto that center point right there. And it says, what diameter circle do you want? I want a 4.5 millimeter diameter circle. And because there's going to be a bolt and a nut over top of that, I want to make sure that I've got enough room to support that. And I'm going to make that 10 millimeters diameter. Okay, and I haven't bothered with any trims or anything just yet. If you're doing this in AutoCAD, of course, because you're actually creating the drawing, you'd be doing all your dimensions at the same time and getting the trim just right. We're just creating a sketch. So I'm just leaving it like it is. Alrighty, now what I'm going to do is I'm going to create that circular pattern. So you come down here, and I had to click on the drop-down menu under Create, and I click on Circular Pattern. Okay, and now it gives me a dialog box right over here. And this dialog box tells me select my objects. So I'm going to do 2 things and carefully select right here, carefully select right here. Now it's possible that you've clicked on something you didn't mean to click on. Okay, so if you clicked on that circle, we don't want that to be in our array. Uh, 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 so, or our pattern, I should say, to use the Fusion term. So if you click on it again, that disappears, and you can watch right up here. It tells you how many objects you've selected. Okay, so pretty easy to do. And then once you've selected the objects that you want to have rotated around, you need to tell it what it's going to rotate about. So click on Select, and you want them to rotate right about there. Okay, beauty, 3 even circles. If you had 4, 5, 6, however many bolt holes you needed to go around there, we've got 3, okay, but you can play around with the quantity and it will space them out as you need them. And let's just click OK on that. And there we go. We've got those in there right now. Now, you'll recall from the design that I also had some pieces coming down right in here, sort of a little triangular bit to come out and cover the speaker diaphragm. Alrighty, now we can create those a number of different ways. And one of the things that I'm going to do is I'm going to just use the offset tool. And let's come in here, and offset is under modify for some reason. Not quite sure why. Okay, and I am going to offset the center line, and I will take it off to the side by, I think, 4 millimeters. And then I will do the offset again. Now you'll notice the letter O is right next to it. I can just type the letter O to get offset, but I'm going to take it in here and I'm going to drag it off this side. And you can see that that changes to a negative because I'm on the opposite side. Negative 4 millimeters right there. Now, I've left this sticking out long and everything like that. I'm not too worried about that right now because I think you're already familiar with the trim command. So T for trim comes in right here, and I can trim this down. I want to get rid of that bit. I want to get rid of that bit. I want to get rid of that bit and that bit. It's giving me little warnings down here saying constraints and dimensions are being removed. But the drawing will still be fine. You can see our constraints are actually showing up right in here as little icons. And those 2 bars right there refer to the parallel constraint right here. And this one refers to a vertical constraint. So we've got these lines constrained to each other. As you get into doing more complex drawings, the constraints become more and more important. And I think you'll do a lot more of that when you do your course in parametric solid modeling next year, quite possibly using Inventor, which is a very similar product. Okay, now I just clear those 2 bits out right there. So now, after doing all that, I can hit escape to get rid of the trim command. And when I highlight this, you can see that I'm highlighting this circle all the way around here, and it's got this part coming down in here, but nothing joined together in the middle. Well, we want to get 3 of these coming out, and it would be nice if we had nice filleted little corners in there. So fillet belongs under the modify command, and you can come in here and you can fillet that, and then it says what radius do you want to fillet it to. 3 works pretty nice. And then you can fillet this corner right here. Oh, I forgot to select the fillet command. It's like, what do you want me to do? Fillet right there, and 3 millimeters. May as well make it nice and symmetrical. Okay, now clicking on the middle mouse button allows me to drag that back up onto the screen. Again, you've got tools down here for pan and zoom, and later on we'll use the orbit tool to rotate around and look at things. But right now we're working on the flat here, and now I'm going to use that, where are we here? That circular pattern tool again. And I'm going to create a circular pattern of these parts that I just created. There we go. And it should say 4 selected, okay? Because I've got 2 radiuses and 2 lines. Okay, now I'm going to select the center point. And there's the center point right there. And it's already got 3 selected. And you can see this all came around and created these lines for me. And those look like they're all in the right place, so we'll hit OK. And let's come back. We could just leave it there, but let's tidy it up a little bit with a bit of filleting on the middle. And 5 mm looks like a nice fillet there. And fillet. And fillet. There we go. It's looking pretty good. Okay, and yes, we've got lines overlapping over top of each other. Yes, we've got dimensions everywhere. That's the brilliance of parametric solid modeling. Watch what happens, for instance, if this 52 dimension is wrong. Okay, now if I've got my parameters set up right, I should be able to say, let's bring that down to 45. And the first one changed, but the second one's down here didn't change. Okay, well that makes sense. We'd have to go back and redo our design because the constraints didn't modify over with that. But had we set them all up with the constraints all tied in there and then gone through and added the right constraints, we could take this design and scale it up and down and twist it and make it fit, and it would keep all of the design intent. Design intent's a big word in parametric CAD that we had originally intended for it. Okay, let's go ahead and turn this into a solid part. We have our sketch all done right now. I'm just using my mouse to move it around and show you that it's nice and flat. It's only two-dimensional right now. Okay, if you wanted to move that around, you can come up here and you can grab on the box in the top corner and you can pivot that around, or you can just click on one of the planes and you can take a look at it from a particular plane. I'm going to click now on Finish Sketch, and then I'm going to come up to the top right here and I'm going to say I want to take a look at it from this corner right up here. So I just clicked on that corner and it rotated so I had more of an isometric view of what I'm looking at. Now, once you've got a sketch created, the trick to Fusion 360 is then you take that stretch and you extrude it. Okay, and just like squeezing toothpaste out of your toothpaste tube, the extrude function comes in here and it says, okay, select your surfaces. So if I select that surface right there, now you have to be careful about which surfaces you select, because if you forget a surface, it's not going to get extruded. Now, you'll see I've intentionally not selected these surfaces right here and this surface right here, because those are going to be holes and they're going to be open. Okay, and so when it looks like that, now we're ready to do an extrude. And this is the part that's going to go up on top of the speaker. Now, right now I've got it set to 3 mm. Doesn't have to be 3, but 3 should give it sufficient rigidity to hold everything together and to protect the diaphragm. So let's tell it we're going to extrude that by 3 mm. And now you see that extrudes it right out of that plane. And you can come up here on the top and you can rotate around to view it from different points of view. I'm just going to use my mouse to zip it around. Yikes. Turn around the way I want you to go. There we go. And you can see extruding 3 mm out there. And it's going to create that as a new body. And I'm just going to click OK. And there we go. So you've got a nice solid 3D part. And quite frankly, we could take that right now. We could send it to send it to Cura and slice that up, and we've got a part that we can model with. And the cool thing is, over on this side of the screen, we've got a list of our sketches, and that was drawn up as sketch 1. Okay, that was our original profile. You can click on that, and you can go back and you could edit that sketch. And so if I came in and edited that sketch right now, all of the changes that I made when I edited that sketch would be reflected in the extrusion that I just did with it. So you can come back and you can modify all sorts of things. We're not going to do anything like that. Now we're going to extrude the rest of the drawing. Okay, so the rest of the part, I'm going to create a sketch right here. So this create sketch command, you get very familiar with it in Fusion 360. And instead of selecting one of the existing planes, okay, the X, Y, or Z plane, I'm going to click on this work face right here. And you can see how the work face highlights. And I'm going to build right on top of that. Now I'm just going to recenter this on my screen a little bit. Okay, and so I'm working right on top of that surface. So if I extrude out from there, then my new surface will be coming out from that side. Now, I've already done a lot of work to create this the way I want. So what I'm going to do is I'm going to project all of this information onto my new sketch plane. This is a super powerful tool that you can, after you use it for a while, you can think about all the different neat things that you can do with it. And what project basically does is it says, I've got a work plane right here, and I've got an object over here, and I want to get the outline of that object as it projects onto that plane. So I take this and I project it right onto there, and it's like it gives me a two-dimensional drawing of this object that kind of exists in the background. And you could choose that for any work plane. So for instance, if you had an angled work plane, okay, coming in like that, and you want to know how that coffee cup projected onto the work plane right up there, it would project it onto the work plane for you. It's really an amazing and useful tool. So I am going to hit P for project, or you can find it under create, project/include. Okay, we're going to project. And when I click on there, you see all those lines go red. Now, all of those lines automatically become part of my sketch. And that makes it really easy for me to figure out what I want to do next, because the only other line that I need, I think I'm going to make the part that extrudes be just a little bit thinner in the wall. So I'm going to come out right here and I'm just going to draw a line right on here. Now, I'm not worrying about the dimension. Okay, just make sure that when you put it in here, that there's no really obvious constraints appearing on it. Just go ahead and click it in right there. And now I'm going to come back and I'm going to do a sketch dimension. I'm going to click on that line. I'm going to click on that line. And it says, where do you want me to put the dimension information? We'll put it right here. And I want that to be 1 millimeter in, just because I can. Okay, just going to space that out just a little bit, make this wall just a little bit thinner, have a little bit of a rim or an edge right on the top right there. Okay, so that is a 1 millimeter gap right in there. You could probably get away with making a 2 millimeter gap. It's all we have to do for this sketch. We've got all the rest of the information that we need. I'm going to click on Finish Sketch right here. And again, I'll take a look at it from more of a perspective point of view so you can see that the sketch is drawn on this surface right here. When I put my mouse over top of this face highlights. So you can see right in there, that face right in there means that I've got one solid continuous face with everything all joined together nicely, which means that's a super candidate for extrude. Okay, I click on my extrude button and I click on that and I tell it that I want to extrude that a distance of 24 millimeters. And you can see I've got options in here like join and cut an intersection or new body. I'm going to join this to my already existing body. And so now, as I go and do that, there's that little 1 millimeter edge that I left right in there. And you can see that these holes got projected all the way through. Okay, and when you mouse over them, you can see the holes are projected all the way through. And my entire part is looking pretty good. I can now come in, I can do an inspect. Okay, it's got a measurement tool. I'm going to see this face right here. Then I'm going to rotate around over here to this face right here, and it tells me it's going to be 27 millimeters from top to bottom, which is exactly what I want it to be. Now, it's hard to go wrong when you're going 3 millimeters and 24 millimeters. That better add up to 27. But when you're doing more complex drawings and you're trying to check and see, well, oh, what's my spacing between this part and this part? It's a really useful tool to know that that's there for you to measure. And it gives you a lot more information about that too. But anyway, so there we go. We now have a part designed in Fusion 360. Now you can do a couple of other little neat things to it. For instance, this is going to be a pretty sharp edge right up around the corner. You can actually do a fillet in 3D, and you can come in here and you can click these edges right around here. And sometimes it'll automatically draw the loop for you. Sometimes it won't. There's different options on here on making that. And right in here, we could give it a 1 mm radius just to curve that in a little bit right there. Okay. You'll see when we do our slicing for it that there's a reason I'm not going too much more than 1 mm. Okay. But 1 mm around there is not too bad. It's just takes any sharp edges off right there. In fact, if you wanted, you could probably come in and I'll just click OK right now. You could probably come in and put a fillet around this edge running around the inside too. And again, keep it pretty small. 1 mm shouldn't be a problem at all, but that just rounds off that edge a little bit for you nicely. Okay, so now we've got a part right here and you can rotate through it. You can look at different surfaces. You can click and spin right up there. The orbit command down here also lets you rotate around and see things right in there. And the pan command lets you move things. The look at command is sometimes useful because if you want to look at a particular face, you can click on it like that. Or if you've got a 3D mouse, you just play around and have fun. We've got one last thing left to do. Okay, this works great. That'll fit beautifully onto our board right like that. The speaker should fit underneath it. We checked the dimensions. They're all good. If you want to double check, you can take measurements with your calipers directly off your Big Bad Breadboard board. But we still need to get a hole for the speaker wire to come out of here. And I want to put a hole sort of directly opposite this hole right here. And I want it to be on that face. Now, one of the problems with putting a hole on a rounded face is it's really hard to find reference points, okay? Because if you're going to dimension something, you've got to give it a reference point. And Fusion 360 needs those reference points. You can't just come along and say, put a hole here, okay? Because Fusion 360 will say, put a hole where? And it wants to know exactly where that hole is going to go. So to help it out a little bit, what we're going to do is we're going to create a construction plane. Now, as we've been doing all along, we started out using the X, Y, and Z planes to get started. Then we used an existing plane of the first part that we'd created to draw the second part of the object. Well, now we've got all these different options on how we can create planes. Okay, and not only can we create planes, but we can create axes and we can create points. And the combination of planes, axes, and points, these virtual construction things in here, allow you to locate parts on your drawing where you want things to happen. Okay, so let's take a look at the most useful one for us right now is we want to create a plane. And because we're working with a cylinder, a tangent plane will be really good. Okay, there's a couple of different ways we could go about doing this, but the tangent plane is going to be our most efficient. And so we're going to create a tangent plane, and it doesn't really matter which surface I choose to make it tangent on. Okay, so long as I pick one of the three surfaces. I'm going to pick this one right here because it's visible right now. And so I select that plane. Now, you'll see that I've got one face selected. And it's assuming that I want that plane to be vertical, but it also needs a reference plane before it can create that. Okay, so for a reference plane, I can come in here and I can select any existing plane. So I am going to select for a reference plane this face right down in here. Okay, and this all came up red. It doesn't like that for some reason. Let's work beautifully the first time I tried it. Let's try changing how many degrees we're at right in here. Now it's giving me an error, not a problem. Let's take a look and just say, give me a little more info on that. Oh, usually it has. Now it's just saying, that doesn't work at all, you idiot. Okay, so that's all right. Click on X for your reference plane. We don't necessarily need that to be our reference plane right there. And now I'm just like, what plane did I use when I was practicing this drawing so it would all come together nice and easily for you? Did I choose that plane? There we go. It was the plane on the same inside right there. I guess the issue with that was that right on here, that one, if it came right through, didn't intersect with a tangent. Whereas this one, if I take this plane and come right through there, it will find a tangent point right there. And we give it an angle of 30 degrees. And if we look at that from the top, that's going to come straight through and over to that side. Very nice. Okay, click OK. Now we've got a reference plane sitting right on here. And our reference plane is located on the outside face right here. And it is at, nice straight line that would burrow right through there if we asked it to. What we're going to do, we got a couple different things that we could do. We could create a sketch. We can do all sorts of different things on here. There is a hole command that you can use, but we're going to show you how you can use a sketch to create the hole. So I click on Create Sketch, and now I click on this reference plane. This is the new plane that I want to draw on, and it whips the drawing around right like that. Okay, now keep in mind that there is stuff inside, so we might want to do a projection. Okay, and we're going to take a projection and just take a look right up here and project this inside surface right here onto that plane. Okay, and now if I go back to looking, oh, I need to look at the exact plane. Okay, I lost my dimensions on here. Remember I said there was a look at command down right here? You can tell it look at, and if you can't select the plane right there, you can find the planes under the construction heading over here and tell it to look at plane 1. It brings it back into this dimension right here. And now you can see that our projection of the interior dimensions right here includes this line. This is our 3mm gap coming up right here. Okay, now what we're going to do is we're going to create a center diameter circle, and I'm going to put it somewhere up and down on this center axis right here. Okay, and it needs to be 8mm in diameter for us to fit the little plug from our speaker through. Now, if you want to get fancy, you can measure that out. You could actually make this a rectangular hole coming through on the side because it is a rectangular plug. But for the sake of keeping it simple on today's drawing, let's just make it round. And now we have to move that off. You see that intersects right there. I don't like that dimension. We can come in here and we can apply a dimension to it. So long as it's not otherwise constrained, I can say, well, take the center right there. And I clicked on that, and now come down here and click on this edge right here. And it says, where would you like that center to be? And now I can come in and I can say, I'd like that to be 8mm up from right there, so it clears that lip right on the inside edge. Okay, so now we've got this hole right here, and I'm going to say finish my sketch. Now if I look at that from this corner of the diagram, you can see that this is sitting very, very flat. Okay, it's not projected onto this surface. Okay, there are tools that allow you to do that, but we don't need to do that because what we're going to do is we're going to do an extrude. Normally when we've done our extrudes, we've extruded in the positive dimension. So I've done the equivalent of dragging on that and pulling it out that way. Okay, but you can drag on that arrow and you can pull it back that way, and you can see that as soon as it starts going back inside, in the operation setting right here, I've got new body, I've got join, I come this way, and now all of a sudden it says cut. And if I go all the way through, let me look at that from the top. Okay, make sure you go all the way through. 11 millimeters should be more than sufficient. If you go too far and come out this side, that hole just keeps projecting all the way through. And you can see that it burrows through on this side of the drawing too. And we don't need two holes for our speaker wire to get out. So we're just going to put the one right on here. And oh, it looks like 10 millimeters was enough. And the cut option is exactly what we want. And we will say OK. And now you've got a hole coming through on that side. And as you take a look at it, you can see it from the inside too. So a couple of different ways that you can put things together. Now, since you've got wires coming through the hole, if you want to get fancy and you like using that fillet tool, because I really like filleting and 3D printing, it's one of the few machining processes where there is no cost to putting a fillet on something. Okay, so now I selected, what does it say, 3 edges? Thought I'd only selected 2. Let's see what happens when I put a 2 millimeter radius on it. There we go. I've got a nicely filleted hole so that there won't be any rough edges to abrade the wires that come through. Let's just check right up and inside here. Now you can see, oh, maybe 2 millimeters was a bit too much because we only gave a 1 millimeter difference right on there. Let's bring that back down to 1. There we go. Now it meets up nicely with that surface right there. And I'm leaving that flat because that's sort of where the rim of the speaker is going to be. This is going to sit down over top of your speaker and hold it all in place. And we should be able to click OK. And now we've got a part with a hole in the side that we can send out to the 3D printer for manufacture. Okay, so let's save that. And you should see it showing up right over here. And once that's saved, we now need to get that out of Fusion 360 so we can slice it up in Cura. So it's saved in here, and you'll notice it updated the version number. You can always go back to a previous version of your projects in Fusion 360. It's really helpful that way. Okay, what I want to do is I want to come into my tools. So in the tools menu right up here at the top, you'll notice that my menu items changed. There is a make setting, okay? And what I am going to do is I am going to go to 3D print. And it says, what objects do I want do I want to 3D print? So I have to make a selection. So I select the part that I just designed. And now you can see it's come through and it's created it in a wireframe. The STL format that we're going to be using uses a wireframe to explain all the dimensions. This is part of the reason why if you download a project from Thingiverse or something like that and bring it into Fusion 360, it can be a royal pain in the butt to edit. That's because it's not a parametric drawing. It's a go from this point to this point to this point to this point type of drawing. And so it works, you can edit it, but you don't have all the nice reference points because it's not a logical explanation of it. It's just a physical representation of the part that you're going to make. Still, the STL format is hugely interchangeable, which makes it very worthwhile using. Now, you might not need high refinement. You can play around with that and see what a low refinement polygon shape looks like. And sometimes that can damage your output resolution. And seeing as how we're not too worried about file size or anything like that, may as well use a high resolution. I'm going to say turn off the send to print utility right there and just click on OK. And now it's going to ask, where do you want to save that? Um, and the desktop's a really awful place to put it. I use a few different folders, but for right now, I'm just going to throw it on my desktop. Make sure you save it in a folder that makes sense for you and give it a name that makes sense for you. So I'm going to call this Big Bad Breadboard Board, 3D printed speaker enclosure JSON. I'm going to add my name to it just to make sure that follows it all the way through so that when we print it, we know whose file we're printing. Okay, that's about it for Fusion. Your file is saved. You've now actually built the part. All the hard work is done. You just need to go through and generate some G code for the 3D printer so that it comes out. So if you're looking for a natural place to take a break and come back in a minute, go grab your coffee cup, your tea cup, whatever other beverage you're having, and congratulate yourself. It's a nice looking part you just made. Okay, I'm going to minimize this window right here, minimize this window right here, and now I've got Ultimaker Cura up and running. Now, the first time you run Cura, it doesn't know what type of printer you're going to use. It doesn't know much of anything. It's got some default settings, but you do need to come in and configure it. So you should be looking at a screen that looks something like this. And what you need to do is you need to come in here and you need to come into your settings and you need to tell it that we're going to add a printer to the system. Okay, now you can see I've already got the monoprice select mini enabled on this system. Yours won't have that enabled. We have the monoprice select mini V2 E3D and ready for you to use in the electronics shop. So let's go add printer. Okay, couldn't find anything over the network. Add a non-networked printer is what you want. And there's a whole list of different 3D printers that have been configured to work with Ultimaker. Now, obviously, because Ultimaker makes their own printers, they put all their software at the top of the list. But because they're using open source components, and they have to make their file compatible with open source rules and regulations. They make, people add in all these different plugins, and it just makes it really easy to use. Ultimaker is a standard, or Cura, sorry, is a standard slicer. Slicer being the program that turns your 3D object into the G code. And we're looking for the monoprice. There we go, monoprice. And you want the monoprice select mini V2 E3D. Okay, and you would come down here and click add. I've already done that, so I'm just going to click cancel. But then that's going to appear in your printer settings up here. So when you come in now to select printer, you should see monoprice select mini V2 as one of your options. And when you click on that, you can see that the bed shrinks down like that because the mini isn't as big as the Ultimaker. Okay. Now, what we want to do is if you're looking at something that says mini, we want to bring in our part. Okay, so we're going to come in here and we're going to open a file. And on your desktop, or wherever you saved that file, I know mine ended up on the desktop, even though I hate saving things to the desktop. I'll go back and delete it later. You should see your Big Bad Breadboard Board 3D printed speaker enclosure, and that part's going to come in right like so. Now, if you got lucky, okay, it came in on the bed exactly the right way around, and it's exactly the right size. If you didn't have millimeters set as your units of reference, or if you started drawing it from a different drawing plane, it may have come in a different orientation. So if that's the case, you have to select the object and click on rotate, okay? And now you've got these three axes around here, and you'll be able to rotate it around. So if we wanted to print it in that orientation, we could. But as I was saying, now as we start to print, you can see these protective covers in the middle are going to need some kind of support material down underneath them. Otherwise, they'll just be printing in thin air. So we want to make sure that we've got this sitting flat on the bed, right like so. Okay, if you need to scale it, if it came in the wrong side, okay, you can come in here and typically, if something came in the wrong size, it either got printed out in centimeters, so you'd need to scale it down by 10% or up by 1,000%, or it came in inches or millimeters, so that's going to be 25.4 to 1, roughly, your ratio from inches to millimeters. So you can try a couple of different ratios right in there, but if everything worked out right, it should look something like this, and it should be sitting there nicely and neatly right on the print bed. Okay, now if we've got the object sitting on the print bed, we're pretty happy with that. We want to check what our material is going to be right up here. So we've got one extruder on our 3D printer, and we need to tell it what material we're using in here. And it says, well, PLA is the one that we're going to be using. Okay, and we can come in here and we can just pick generic PLA. And it will ask if you want to keep those changes. Now, when you choose your material, some of the changes that you get in here, the build plate temperature. So that is the bed of the printer, has a heater built into it, and it will heat that up to 60 degrees Celsius to help things stick. And with our changes for generic, now mine's saying 40. If yours says anywhere from 40 to 60, you're probably doing just fine. And your print temperature, if it says anywhere from 200 to 220, you're probably doing fine. I find 40 degrees and 210 works very nice with the Monoprice minis. Okay, and so I'm just going to click on keep the changes right in there. Okay, I didn't mention the rest of the settings for that because we're going to go through and take a look at that in Fusion. So we've got generic PLA selected as our material. Now, our print settings right in here. One of the big things when you're 3D printing is what layer height are you going to work with, because that's how high up the print head will come on each layer that you print. And the finer that is, the longer your object takes to print, but the better the print quality of your wall. Typical ranges for a lot of the printers that we have are somewhere between 0.1 millimeters, in other words, 10 layers of printing per millimeter, to about 0.3 millimeters. And they all kind of work okay. The 0.3 millimeters will print roughly 3 times faster than the 0.1 millimeter, but the 0.1 millimeter will come out looking a little bit, finer. Sometimes you'll get a little bit uneven numbers in here, and that's got to do with somebody's gone through and calculated the very optimal layers for your particular printer. I'm just going to come in here and see what else we have, because fine is a little bit slow. Let's take a look and see what normal does for our printer, okay? And so that changes some of our settings. And again, it says double check all of your settings in right here, and we'll say keep the changes. Okay, so now because we've changed up, we've got all these options showing in here. So our layer height is 0.175 millimeters. Shell. Okay, if you click on the drop-down menu in here, is going to show you some interesting things. Now, FX means that it's calculated as a function. You don't really need to worry about that right now. The wall thickness is how thick the wall is going to be. There's going to be three passes of the extruder over top. Standard extruder size is 0.4 millimeters. Top bottom thickness is going to be 0.72 millimeters, so that should all be fine. We'll take a look at more what that means after we slice it for the first time. Your infill density should be down around 20%. And I'll show you what infill means as we go through and do that as well. And you've got different infill patterns, all sorts of different settings. Our material we've already selected. If we weren't happy with the temperatures, we could change it from 210 and 40, but 210 degrees to melt the plastic as it comes out the extruder, 40 degrees for the bed temperature so it sticks to the bed and doesn't warp off the bed. Um, our print speed, this has already been selected for our printer. Yes, you can change them at your own risk. If you set them too high, then the printer can't handle that print speed. And yes, it prints faster, but you get garbage. So slowing it down, takes longer. Sometimes you get nicer print quality. These are pretty optimal for the Monoprice Mini. Your travel settings, retraction means as it's extruding the plastic through there, every now and then it comes to the end of printing a line. Retraction just pulls that back a little bit, and it can enable slightly nicer print jobs. Cooling, there's a fan on the print head that blows down and cools over everything over top. And you heard me talking about support material earlier. I'm not going to delve into it too much right now because we don't need it in this configuration. But if we did need support material for some print or the other, you could turn it on right in here. Build plate adhesion. Okay, we've got a few different options: skirt, brim, raft, and none. I'm going to leave it at skirt, and I'll show you what that means in just a moment. And dual extrusion is not an option on the Monoprice because we've only got one extruder. On the Ultimaker, you can do dual extrusion and you can do all sorts of neat things. You can have your support material printed in one material that dissolves nicely in water, or you can do two color prints on there, or two different materials so that you can print a wheel and a thermoplastic rubber tire around it as well. Well, everything's a thermoplastic in here. Okay, so there we go. We've got all of our settings tapped in there. Now, I say all of our settings. There are quite a few more settings. If one of the settings that I adjusted doesn't come up for you on here, so for instance, let's take a look at, where is one of these ones where it's got a little gear icon over top of it. So for instance, where's one that I like to tweak sometimes? Bed adhesion, where build plate adhesion. Okay, so you can see when I mouse over top of that, a little gear comes up. This is a simplified view of all the different settings available. It shows you everything that you need as a beginner, so don't panic. But as you use the printers more and more, you can come in here, and these are all of the settings that you can tweak for build plate adhesion. So if you want to take a look at different settings for making a raft, or different settings for your brim or your skirt, you can come in here and play with them. But for right now, you're probably happier if I just close that and say, I never mentioned it. You don't need to know anything about what those little gears do. Okay, good. We've got this all set up. Now we get to do the very exciting thing and slice it. And now I'm on a lower resolution screen and my slice is tucked away right down in the back. I guess I have to come in, grab those three dots, lift that up a little bit so I don't see as much. And you should see a blue slice button sitting down here, right there. There. Click on that slice button and you'll see it says slicing, and then it will finish, and right in there you'll see a preview button. So click on your preview. And now you can zoom in a little bit. That centermost button helps for moving things around, and take a look at how things are working. Now, right above me over here, right up there, is a slider. You can see we've got 153 layers. And as I start sliding down, you can see some of the things that we were talking about. Okay, so this is the finished project, and it's going to start out all the way down at the ground. This is layer one, the first layer that's going to be printed on here. This is the skirt that I was talking about. Okay, now this doesn't actually help with the bed adhesion. What it does do is it lets any old material in the extruder get extruded out and get put onto the print bed, and it lets you check to make sure that everything's actually going to stick before you start printing your part. Then it's going to come in here and it's going to start printing the walls. Okay, and you'll notice that when you take a look around here, you'll recall we gave it a wall thickness, and it calculated how many, or we told it how many passes we wanted. It calculated the wall thickness. You can see we've got 3 passes of that extruder going around to create our wall thickness right here. Okay, and then once you've done those 3 passes to create the wall thickness, you come in here and it starts going back and forth and putting fine layers of plastic down to create a solid layer of plastic on the bottom, and that's going to stick to the bed. Okay, and you see it's figured out where the inside of the holes are. The software is just amazing. Now, as I go up, layers 2 and 3 are also solid. But as I get up to layer, where are we? 5? Is 5 solid as well? 5 looks pretty solid. Now, as we get past about layer 6, we formed that. Well, it's going to eventually be our top layer, but right now it's the bottom layer because we're printing upside down to our final orientation. And now you can see these cross hatches starting to come in here. Okay, this is our infill. And when I said we wanted about 20% infill, you can see that it's creating a fairly hollow shape. This is one of the neat things about 3D printed objects, is that they're fairly light and efficient on plastic because they tend to be hollow on the inside. In this case, 80% hollow. It's pretty hard to create projects that are hollow on the inside, and it saves, or it can save, a lot of weight and a lot of material. So as we start coming up, it keeps building up and the layers start to add on top of each other. And then you can see we left a little lip right around on that inside of the 3mm part. So you can see that everything just went in a little bit. And now right over in this corner, now you may have your drawing rotated a different way, but somewhere when you get to about layer 22, you'll see this yellow starting to form. Well, that yellow is the bottom layer of the circle. And you can see that hole that we put in the wall is starting to form right in here, and our wall just stops right there. And we keep going up and up and up. And now those layers start to come together. Now, because we're coming together very gently at the top and we don't have a very steep angle yet, the printer can actually do that without the plastic all falling back down underneath it. You can print slight overhangs on here. Let's see what happens as we keep going up on here. And now we're coming in around to the top, and you can see when we get to the part where it would be super steep and go right across the top, it comes in here and it starts doing a bridging operation. It'll take a piece from this side and draw that filament right across down here. And it pulls that bridge, and instead of the plastic drooping, as it cools a little bit, the plastic tightens up and holds itself into place right there. And we can actually get pretty clean holes this way. So depending on the size of the hole, you can probably get away with something like that without support material. Zoom out a little bit here and take a look. As you get taller and taller, you get more and more of the same until it comes up to the top, and then we get our final few layers and it seals it off, and we have a project that looks like a solid enclosed project, but in reality, as you just saw, it's about 80% empty inside. Now, very useful down here. It gives us an estimate of how long it's going to take to print the project, 3 hours and 24 minutes, and about 27 grams of material. So there we go. That's going to create G-code for us. Now, you can click on Save to File. Okay, and this is why I was putting my name and everything. It saves it right on there. Save it to your disk, and you can put it on a flash drive and bring it into work. Or if it's on your laptop, bring your laptop into work. We actually transfer the files to our 3D printers using Wi-Fi. That's a process that I can show you once you've got a file to transfer. Remember that it's the G-code file that we want. This G-code, you can actually go in and look at it using the same G-code editor that you've been using in your G-code class, where you've been learning to manually write G-code. And it's got all of the same commands in there, G0, G1. It's got the X and Y coordinates. You'll see a few different things for temperature and for extrusion speed in this G code because of course we've got the 3D printer and it needs some temperatures and some extrusion rates, which you don't have in a CNC router. But it's just G code, just a lot of lines of it, all automatically generated to do that for you. You can picture how hard that would be to do if you were doing that by hand. So save your G code, okay, and then you can bring it into work and print it out. And then you'll be able to replace your laser cut piece right here on your BoomBot with a nice brightly colored 3D printed piece on your BoomBot. BoomBot. Oh, project that the second years are doing on your Big Bad Breadboard board. Too many B's in the world. Okay, save that file up, and if you've got if you put a flash drive in, it will give you the option of saving it directly to the flash drive right down there, and bring that G code into class, and I'll show you how to hook that up on the 3D printer. If you find this interesting and you're having lots of fun with it, well, it's not so hard to create parts, and I'm sure you can think of some useful things that you'd like to make on here. Have a good afternoon, and there you go, creating a part in Fusion 360 and slicing it in Ultimaker Cura.